Hello and welcome to ASAP Math. In this video, we'll talk about the basic rules in getting the derivative of a function. With numerous amounts of steps, mathematicians develop 5 basic rules, namely constant rule, constant times a function, product rule, quotient rule, and chain rule. To help us solve the derivatives of the functions with ease, my friends at ASAP Math will further discuss the rules. For now, enjoy the lesson.
Constant rule. F of x is set of all real numbers, example 6, and f prime of x is equals to 0. Constant rule, and this is the final answer.
Discuss how to solve a constant times a function. Example: f of x is equals to 6x raised to 4. The formula for constant times a function is c times f of x, then c times f prime of x. So this is the formula of constant times a function. So we will multiply 6 to the power of 4. So 6 times 4 is equals to 24. In the rule constant times of function, you will subtract 1 to the power. So 6x raised to 4 minus 1. So 6 times 4 is equals to 24. Then 4 minus 1 is equals to 3. So the final answer is f prime of x is equals to 24x cubed. So this is the final answer.
Next rule would be product rule. If you're going to use the product rule, don't forget about this formula. G of x times k prime x plus g prime x times kx. So this is our example. Fx is equal to 6x cubed times 7x raised to the 4th power. Let this first function would be g of x, gx, and let this second function be kx. Alright? So using this formula, so copy g of x equals to 6x cubed, and then you're going to multiply it with the k prime. So times, since following the past two rules, you would multiply 4 to 7, so it would be 28x. Minus 1 of the exponent would be 28x cubed. And then we're going to do the same on the other side. So plus, going to find the g prime, which is 18x squared, and just copy times 7x4. And then you're going to now just simplify this. So like you're going to just multiply and multiply this as well. So this will be 28 times 6 would be 168 times x 6th power plus 18 times 7 would be 56. 7, 5 would be 126 x raised to the 6th power. Since these are both 6 to the 6th power, you could add them. So 168 plus 126, it would be 294. x raised to the 6th power. And this would be your final answer.
So we will discussing the quotient rule. And the problem is 5x minus 1 over 6x squared minus 2. First we need to apply the formula and substitute it. This will be the kx and this will be the gx. Then apply the formula. F prime of x is equals to 6x squared minus 2 times the derivative of gx, and that will be 5 minus, just copy the gx, minus 1 times the derivative of k x will be 12x over, just copy this and apply the square. Just 2. Then just contribute this 5 to the first two terms. 5 times 6x squared is equals to 30x squared. 5 times negative 2 is 10. And then just copy the sign. And then just contribute this in the next two terms. 60x squared minus 12x.
Let's talk about chain rule. Chain rule is all about finding the derivative of a subfunction and then the whole function. It goes like this. We first need to find the derivative of 2x plus 3, and that is 2. And then find the derivative of the whole function, which means bring down this one, and we will go times 5. And then we are going to minus it by 1, and that is 2x plus 3 raised to 4. And then we're just going to try to simplify this, and your answer will be f prime of x is equals to 10. 2x plus 3 is equals to 4.
Since now we learned all about the different rules in getting the derivatives, let's talk about differentiation and how it can be applied in real-life situation. So take a look in this video below. So yeah, suppose that you are this person, you're that little guy over there. And then you're a student that is studying about the bacteria, a species of bacteria over there. That's your bacteria species. And you're now encountering this problem, right? Suppose the bacteria population grows at a rate proportional to the population. There were 200 bacteria 3 days ago and 1,000 bacteria 1 day ago. How many bacteria will there be tomorrow? So to answer this, you're going to follow the exponential growth. So when in exponential growth, this is the formula. P of t is equal to AEKT. But first, we don't know what's A and we don't know what's K. So A is the initial value and K is the rate of growth. But we all do know is that P negative 3 because it's 3 days ago is 200. So and P negative 1, which is 1 day ago, is 1000. So 200 is equal to AE negative 3K and 1000 is equal to AE negative K. The reason we have negative 3 because according to the formula, there's a T over here and there's a T over there. So you're just gonna substitute it. And then the question is, what is the number of bacteria 1 day after or tomorrow? So we're going to take this to problems are given, we're going to divide them both. So AE negative 3k over AE negative k equals 200 over 1000. So we could cancel and then you're going to be left with A negative 3k and E negative k. So now you're going to have 1 over E2k equals to 1/5 because 200 over 1000 is 1/5, and this became a positive one because if you're going to put negative over the denominator, it will become positive. So with this equation, you can now have 5 equals to E raised to 2k, and to make it more simple, simple, we're going to have to find or use the natural logarithm. So ln 5 is equal to ln E2k, and the natural logarithm of E2k will be 2k. So you're now going to divide 2 to ln 5, so you're going to have ln 5 equals over 2 equals k. So now you now know what's k, and the only thing you're going to find now is a. So before that, let's make this formula simple, since we're now going to substitute ln 5 over 2 as the k, and then we're going to simplify it. So AE raised to ln 5 times 1/2 because it's over 2. If you're going to put it up here, it's going to multiply to 1/2, and times t, because we're still going to just follow this. All right, don't forget the t. And then since E raised to ln 5 will just become 5, so A times 5 raised to 1/2 times t. And then if you're going to make it, you're just going to bring this down again, and then it will be very simple, a simple formula, which will be pt equals to A times square root of 5 times t. So now we can now find A better with this formula. And then in this next step, we could use either of the two given over here, so we're just going to choose -1. Okay, so p -1 equals to A times square root of 5 times 2 raised to -1 is equal to 1000, because it's right here. It's just the same. We're just going to put the k here. We're just going to put all the substitutions that we had found out a while ago. So since this is negative, you could now put A over -5 equals 1000, and then soon you're just going to find that A is equal to square root of 5 times 1000. So now you already know what's A, and you already know what's K. And then all that being said, we can now find what's the final answer. So now pt is equal to square root of 5 times 1000, which is the A, times square root of 5t. Alright, since now we're going to just substitute with 1, and then the time over here 1. So our final answer would be, the next day there would be 5,000 bacteria, and that is the exponential growth.